Hi, I'm Tatiana Cook, a Senior Technical Product Manager at AWS. Today, I'll be sharing more about the AWS Outposts service and our new smaller form factor options that we're pre-announcing this re:Invent. As an overview of what we'll discuss today, I'll be covering the challenges that customers say they face managing on-premises infrastructure. I'll describe the AWS Outposts service, which enables a seamless extension of AWS applications to your premises. Then, I'll cover the new server form factors for Outposts that we're pre-announcing now. We'll cover their hardware specifications, how you can get started using the service with these form factors, and design considerations you may want to take into account as you're deploying to the edge. Customers have told us that they face a variety of challenges managing on-premises workloads. Customers want to benefit from the advantages of using the cloud. These include ease of use with consistent APIs and tools, flexibility that comes with a range of managed services, the reliability of running on AWS managed infrastructure for critical applications, the benefits of deploying to AWS's global footprint to address customers located around the world, and security. However, not all applications are easy to migrate to the cloud. As shown here, the workloads on the left-hand side are easy to migrate to the cloud and often include things like email, collaboration tools, and web applications. In the middle are workloads that involve data that needs to remain in a particular country because of regulatory constraints or compliance. These can run either in the cloud if a region is located in an appropriate geography, or using an on-premises solution, depending on what's available in the geography where the workload is located. On the right-hand side are workloads that are harder to migrate for two primary reasons. First is workloads that require local data processing because they involve large data sets that are generated at the edge, which may be difficult to move to the cloud or may need to be accessed during brief networking outages. There are also latency-sensitive workloads. These are workloads that require sub-10 millisecond response times to end sensors, on-premises equipment, or users. Because of this, it takes too long for a signal to be sent from a customer site to the cloud, making it difficult to migrate these workloads off-premises. Customers who can't move certain workloads to the region because of data residency, local processing, or latency requirements then have to build and maintain on-premises infrastructure at their facility. This introduces complexity in several ways. First of all, for the IT infrastructure team, there's a complex procurement and provisioning process to bring new structures to their premises. They may have to work with multiple vendors and have months-long lead time to get infrastructure up and running, even if their workloads are scaling more quickly than that. They have overhead to patch and upgrade applications that are running on premises, and they may need to schedule maintenance downtime or arrange for on-site resources every time they have to make an application change, which can impact their operations. Then there are developers. Developers end up having to build for different APIs and services. They may need to use different tools for automation, deployment, and security controls. This results in separate code bases and processes for on-prem and the cloud, creating friction and operational risk. Both of these lead to business challenges that organizations face. Things that slow the pace of innovation. Because on-premises lags the cloud, customers have delayed access to new technologies and longer deployment timelines from testing to production. This affects a business's ability to respond to changing market dynamics and to be nimble in terms of delivering new solutions that bring value for themselves and their end customers. We heard you, and that's why we launched AWS Outposts to general availability at re:Invent last year. AWS Outposts is a service that brings AWS to your premises. With Outposts, you can develop once and deploy in the AWS cloud or on premises without rewriting applications. You can use the same hardware and software infrastructure for a consistent deployment environment to run cloud-native applications anywhere. The Outpost service is fully managed and monitored and operated by AWS. This includes things like automatic updates and patching and repair notifications sent through the same systems that you use for the cloud. Customers have a single pane of glass management with the same AWS CLI, management console access and integration, which allows them to automate, govern, and use security tools that they would use in the region. Let's talk a little bit more about how the AWS Outpost service works. Outposts is a fully integrated service that connects the region to infrastructure located on your site. An outpost is a logical construct that is used to pool capacity from one or more racks of servers that acts as an extension of an AWS availability zone. Customers can extend architecture to span the AWS region and their site, and use Amazon Virtual Private Cloud Networking to securely send signal between local and regional workloads. Outposts also include a local gateway, which integrates the outpost to their local network to send and receive signal with low latency for seamless networking with on-premises data sources. Outpost racks support scalable workloads, so you can start with a single rack and scale to more than 100 racks of capacity within the same outpost pool for simple management. Today, the Outpost service runs on capacity provided by 42U tall AWS-designed racks that are ideal for data center-grade workloads. To use an Outpost rack, customers provide a rack position in their data center or colo facility, 5 to 15 kilovolts of power per rack, and we recommend a 1 gigabit per second network uplink path to the AWS region. With Outpost racks, AWS handles delivery, installation, and maintenance. After a rack is installed, AWS remotely maintains infrastructure for customers. These racks are designed to scale to large installations that can have dozens of racks of capacity. And they include fully integrated network management that makes it simple to add that much capacity at a single site. Customers can then run a wide range of local compute, storage, database, and analytics services on premises using the Outpost service and rack capacity. We've gotten a lot of positive feedback and interest since our launch last year, but some customers have reached out about on-premises workloads at sites where a 42U rack is just too big. These customers have local processing needs. Data needs to be available for analysis and user access locally. They need low latency response times to address local equipment or users. Examples of these locations include retail stores or enterprise branch offices that have latency-sensitive applications like payment processing systems. It includes healthcare providers who generate large volumes of patient data on premises. Sites also include factories, warehouses, and distribution centers with automation initiatives, but where there may be constrained bandwidth out of the site that makes it difficult to migrate everything to the cloud. In all of these cases, customers want the benefit of the AWS Outpost service to simplify deployment, development, and management. But until now, they've had challenges to provide the space, power, and network bandwidth required for a full rack. We're excited to be announcing new server form factors that will help bring Outposts to more customers. Based on customer feedback, we will deliver a smaller form factor option in 2021 that is ideal for sites like restaurants, hospital clinics, warehouses, or cell towers. These servers can be integrated into existing customer spaces. To make this simple, customers will be able to order rack-mountable servers that can fit into existing rack space. For example, racks with network switch equipment that might be on site at a retail location. We'll have 2 different SKU options that are 1 and 2 rack units tall respectively, and both of which will fit into EIA 310 19-inch width standard racks. Each server will have a lower power draw and lower bandwidth requirement than the smallest Outpost racks today, making it possible to bring the AWS Outpost service to a new set of sites. Using the Outpost service and smaller form factor SKUs, you will be able to run compute applications at the edge for low latency and local data processing. You'll be able to run virtual machines with EC2 instances. Each instance will have instant storage that can be used for Omni launches and data volumes. You'll be able to deploy containerized workloads using container services like Amazon ECS or EKS. You'll be able to network using Amazon VPC to introduce logical separation between workloads and secure communication within a workload that spans the region and your site. We expect that these will be a great option for IoT workloads, so we're qualifying IoT Greengrass for IoT messaging and SageMaker Neo for inference at the edge to run on top of the Outpost server devices. Using this new form factor option, you will be able to deploy apps using the same Outpost logical constructs you may be familiar with today. Instead of deploying 1 or more racks, you'll be able to deploy across one or more local servers. To do this, you can start by creating an outpost. As part of server installation, you will set up the network link between your local resources and the AWS region over an internet or direct connect connection. You will also create a local gateway to map to on-premises network traffic. You can order one or more servers that are associated with the same outpost ID, which will logically group that capacity together. From there, you can use tags and tools like CloudFormation to automate provisioning, deployment, and fleet updates across global locations, including hundreds or even thousands of sites. From a logical resource connection, you will be able to see your outpost with local capacity from the console or CLI, and create a subnet and associate your VPC with the outpost, just as you would associate subnets with an AZ in the cloud. Instances in the outpost then securely talk to other instances in the VPC through private IP addresses. You can build with both local services like EKS within your outpost subnet and connect to AWS services in the region through public endpoints or privately through a VPN. Now with this new form factor, Outposts can help customers operating across a range of smaller sites. These include retail stores or enterprise branch offices that are running point-of-sale systems, security monitoring, network administration, or smart displays. Customers may also be developing next-generation facial or voice recognition apps to customize their customer experience. With Outposts running on this new server form factor, customers will be able to integrate those local applications and insights that are generated to data lakes and ML models that are aggregating information in the cloud across hundreds or thousands of operating locations. Healthcare providers will be able to use Outposts for a range of hospitals and clinic sites, regardless of size, perhaps deploying Outposts running on racks at a larger hospital network and an Outpost running on one or two servers to a smaller clinic. They will then be able to use the latest technology to assess patient images or process medical data quickly, benefiting from the cloud, tools, and long-term storage for management of any findings about patients. Factories, warehouses, and distribution centers will be able to bring compute to the edge. This will power automation, and customers will be able to integrate IoT data, monitor systems, and provide feedback to operators quickly, regardless of whether or not it's a large site or a small site with only one or two servers. Now, I'll go over how you will be able to get started with Outposts and these new server SKUs. First, we'll talk a little bit about prerequisites, and then we'll cover the 3 steps it takes to run applications on premises with Outposts: ordering, installation, and launch. Before ordering, the prerequisites that are required to use the Outpost service for this server form factor are similar to those we have for racks today. As a customer, you'll need to provide space, power, and networking for the Outpost servers. Each server will need 1 to 2 U of rack space available within an existing customer-provided rack. You'll also have to make sure that you can establish a network connection from your site to an AWS region. This means providing network switches with physical 1G or 10G uplink ports, and an internet connection through an internet service provider or through AWS Direct Connect. You'll need to either make sure that someone from your team, like a site manager, is on premises when the server arrives for install, or that you have a third-party resource who can come to your site and help get the equipment in place. Finally, as with Outpost racks, you'll need AWS Enterprise support to use this service. Enterprise support provides 24/7 technical support, including a team of Outpost experts who are trained to help you get your applications up and running. We will publish more details about server specifications as we get closer to our launch in 2021. Now we can get started. First, you'll be able to go to the AWS Management Console. You will create a site capturing information that we'll use for delivery, like the address of your site and any unusual power or networking details. Then you'll create an outpost. This resource will be used to manage your local capacity. You will be able to use tags to group your sites or your outposts together. For example, you could tag all of the outposts that will be used for your Northeast regional deployments. Once your outpost is created, you will be able to browse the Outpost catalog to find the SKU that you want to order. You will then select that SKU and submit an order. You'll be able to track this using the console dashboard and alerting tools to check the fulfillment status as the servers are fulfilled and shipped out to your site. At launch, we'll also support ordering through the AWS CLI and SDK, so it's easy for you to automate large-scale fleet deployments. Once you've placed an order, the Outpost server will be fulfilled and delivered to your site address. When it arrives, your on-premises resource, let's say Sally the site manager, will be able to unbox the server and, following basic directions, mount the server into your rack and plug cables into your power and networking. Once connected to your network, the server will phone home, calling back to AWS to establish a secure network connection that will be used for management. AWS automatically provisions and configures the server from this point on, so Sally can relax as her job is done. Once provisioning is complete, you will be able to see that there is an active capacity pool associated with your Outpost using AWS regional management tools like the console. Up to 6 servers at a site can be configured as a single pool within the same Outpost, so you could start with a single server of capacity and add more servers over time as your workload grows. If your workload is much larger than 6 servers, get in touch with our team, as a rack form factor may be more appropriate to support you when your workload grows over time. Now that your Outpost is installed, we can talk about launching workloads. You'll be able to see your EC2 instance and instance storage capacity from the AWS management tools. To launch a workload, you'll create a subnet associated with your Outpost. You will then associate the VPC with your local network to send and receive network data. Let's say that you want to aggregate IoT data from Sally's inventory scanner. Setting up the VPC enables you to securely receive and process local signal to send Sally alerts when inventory is running low. You can also target more workloads to deploy locally, like image processing apps or network management tools over time, and you could segregate those by creating new VPCs that extend to this local Outpost running on your servers. Outposts are integrated with management tools like CloudFormation, CloudWatch, and Code Deploy that make it easy for you to build and test in the region and then automate deployment to many production sites with Outposts. Now that you've gotten started, we can talk more about how to design for the edge with Outposts. The Outpost service delivers a truly consistent hybrid experience. This means that you can build using the same native AWS tools and services. There are a few considerations that come with deploying to on-premises capacity that you can keep in mind as you start to test and deploy to Outposts. First of all, it's worth thinking about the advantages that come with running a hybrid AWS cloud. You can begin to design using AWS native APIs and tools. You can use CloudFormation and Code Deploy for deployment, CloudWatch and CloudTrail for monitoring and logging, and tools like IAM and KMS for identity and access controls and security. Outposts is part of the overall shared responsibility model that applies to customers building with AWS. Under the shared responsibility model, AWS manages the security of the cloud, while customers manage their security in the cloud, for example, of their applications. For Outposts, in addition to this, customers are responsible for providing space, power, and networking. So you should think about how to provide consistent power and networking for the best availability and uptime once you have servers installed on your site. For security, Outposts are integrated with cloud security tools. Data on Outposts is encrypted by default at rest and in transit over the secure link back to the AWS region. For data destruction, Outposts devices also include a removable physical security key that will be used to effectively shred any information that's on a server before it's sent offsite for repairs or at the end of your term. If you're thinking about availability, each server is designed as a field replaceable unit, which means that it's simple to remove it from the rack that it's been installed to and ship it back for repair. We'll issue retirement notifications in the same way we do for workloads running in the AWS region if a health issue is noticed, and we'll consistently be monitoring infrastructure so we can reach out at the appropriate time to perform any repairs that are required. We recommend considering redundancy depending on your site's requirements so that you would deploy, say, 1 or 2 extra servers such that any hardware events don't affect your application uptime. Outposts are designed for connected operations, but they're statically stable during brief disconnects. What this means is that applications that you had previously deployed, like an EC2 instance you've already launched running a VM, will continue to run and be accessible. We'll also surface networking alerts so that you can tell when a site goes offline and be able to reach out to your local team to take action to try and bring it online in a timely manner. We're really excited that now the Outpost service is providing two different kinds of form factors so that you can build and deploy to locations regardless of the size and power that's available. You can use racks for on-premises workloads that scale to hundreds of servers or capacity, or you can use Outpost servers for compute workloads at sites with constrained space. In both cases, Outposts address customer challenges like low latency requirements for fast response times and local processing at the edge to help make sure that you can respond to the data where it sits and take advantage of compute where it needs to be. The integrated Outpost model simplifies IT management, streamlining operations by allowing you to use and build resources just as you would build and deploy to the AWS region. There are operational benefits, especially for customers who are thinking about how to manage IT integration across hundreds or thousands of sites. AWS is comfortable operating at scale as we do in our data centers today, and we're excited to bring this operational model to customers who have more workloads at the edge. A simple ordering process makes getting started fast, enabling your business to move quickly instead of being blocked by multiple IT vendors and months-long deployment times. Your developers can now build and deploy anywhere, and coming soon, you'll be able to use this same approach to give them a consistent deployment environment, regardless of whether or not you're operating out of data centers or edge sites. Outposts in both rack and server form factors are part of a range of AWS options for different needs. And we think Outposts are great for connected sites, but there are a few different services you can consider depending on your constraints. From the far edge with microcontrollers and IoT devices, to rugged and disconnected locations where Snowball family products meet customer needs, to networked on-premises, where depending on your use case, you can use a combination of Outposts, storage gateway, SiteWise for industrial IoT, or RoboMaker for robotics. We're now also offering 5G telco services with wavelength, and if you need low latency but are close to a region, we're adding more regions, availability zones, points of presence, edge locations, and local zones all the time. The big message here is that while we are very excited about Outpost servers and are looking forward to sharing more next year, AWS is committed to meeting you where you are operating with the right set of services to meet your use case, whether you have data residency, local processing, or low latency requirements. Thank you so much for joining. Again, I'm Tatiana Cook from the AWS Outposts team, and we'll be excited to bring you more and more information about Outpost servers.